Okay, so let's go through one of the very common mistakes that a lot of people make when we do integrals. So you see a rational function right here, and then we're going to try to take the integral and evaluate it from -1 to 2. So if you remember the power rule, the integral basically says if I take the antiderivative with respect to x, you will have x to the n plus 1 all divided by n plus 1. So using that idea, you can consider x cubed as x to the -3. So the expression basically boils down to -2 over x squared, and then you're going to evaluate it from -1 to 2. If you plug in the numbers, the first number is going to be -2 over 4. You're going to subtract -2 divided by 1. So it simplifies into -3 over 2. Looks good, right? But it turns out that this is actually not a proper integral. It's not one of those things where we are allowed to do these calculations, okay? Why? It'll make sense when you actually graph it. The graph of 4 over x cubed, as you can see, you have a variable on the denominator. So when you have things like that, by the time you're doing calculus, most people are aware of this, but you have to be very mindful that if x is 0, there's going to be a division by 0, so many weird things could happen, right? So the integration limit is from -1 to 2, which actually includes 0. So if I take a look at it, the graph roughly looks something like this. And then what we're trying to do is to try to evaluate the values from here to there, quote unquote, under the curve, which goes all the way down to infinity, comes all the way up from infinity, and then we're trying to calculate that area. And as you can see, it blows up very quickly. So it doesn't make sense to say that it's going to be -3 over 2, especially because we know that this portion looks like it's going to be bigger than at least this portion, right? So things doesn't make sense when you don't do the proper, when you don't follow the proper rules. In this case, this is not a continuous function between the interval -1 to 2. And that makes this an improper integral. So you have to take steps to make sure that you're doing it the correct way.